Okay, so in this video I'm going to have a look at parametric differentiation. And this is where we have to find dy dx, but y and x are given in terms of a third variable called a parameter. And this parameter can be anything really, but usually it'll be t or theta, something like that. I'm going to use t and theta anyway. So x, for example, will be given as some function of t. Let's say y will be given as some function of t. Well, we'll call it g, actually give it a different letter here. So x is some function of t, y is some function of t, and what we want to do is find dy dx. We want to differentiate y with respect to x. And they're combined, if you like, or related because they're both functions of this variable t, the third variable, this parameter. So how do we do that? Well, what we do is we differentiate x with respect to t first. So we find dx dt, then we find dy dt. So in order to find dy dx, you can see y is on the top here, x is on the top here. So if we want dy dx, we want dy on the top, we want to multiply that by, we want dx on the bottom here, and our third variable here will be t, so we want dt down here and dt here. So this is dy dx really. So we can find dy dt by just differentiating this function here. We can find dx dt, but we need dt dx, which is the inverse of this here. So really what we need to do actually is just take dy dt and actually divide by dx dt. Remember, if you divide by dx dt, it's the same as multiplying by dt dx. You flip this upside down and multiply. So really this is what we want to do here. So dy dx will just be dy dt divided by dx dt. We can find dy dt by differentiating this function and the x dt by differentiating this function here. So this really is what we're going to do. Now what I'm going to do is I'm going to do two examples of parametric differentiation. So let's look at our first one. So the first one, we're going to say that x is equal to, let's say, 4t cubed. And I'm going to say that y is equal to 1 plus 3t squared. And we'll square that as well. And what we want to do is find dy dx. We want to find dy dx. So let's start. First thing we need to do is find dx dt. We need to differentiate this with respect to t, and then differentiate this y here with respect to t. So what we're looking for, as I say, is dy dx in terms of t. So let's find dx dt first. Okay. So dx dt, just differentiate this here, that will give us 12t squared. Okay, so next thing we want to do is find dy dt, so we want to differentiate this with respect to t. So dy dt, so here we got to use the chain rule because this is a function of a function, if you like. It's all of this squared. So let's differentiate the whole thing first. That will give me 2 times 1 plus 3t squared, subtract 1 from 2, that'll give me 1 here. Now I've got to multiply that by what I get when I differentiate what's inside the bracket here. So that will give me 0 plus 6t, so just 6t here. Let's just simplify that. That will give me 2 6s 12, and that'll give me 12t. 2 6s 12t, and inside the bracket 1 here. So let's see, 1 plus 3t squared. Okay, so I have dx dt, I have dy dt. So what I want to do now is find dy dx. So let's do that. So dy dx, as we know then, is going to be dy dt divided by dx dt. So in this particular case, that's going to be dy dt here, so that's going to be 12t. 12t times 1 plus 3t squared, and we're going to divide that by dx dt. dx dt is 12t squared. Just come up here now. So that's going to be equal to, well, the 12's here, the 12 will divide into 12 to give me 1. This t will divide into this t squared to give me t on the bottom. So really I'll just end up with 1 plus 3t squared on the top, and on the bottom I should just end up with t. So I think that's just about it. Yeah, 1 plus 3t squared divided by t. So if you wanted to find what dy dx was at any particular point t, you could just put the value in here. So if t was equal to 1, for example, put 1 in here and 1 in here. That will give you 1 plus 3, which is 4, and so on. So I won't do that a little bit, but you get the idea. Dy dx then, in terms of t, then is 1 plus 3t squared over t. Okay, so that's my first example. Let's do another one. Okay, so the next one a little bit more detailed, but it's the same idea again. Okay, so in this case I'm going to take x is equal to, so x in this case is going to be equal to 2 times theta plus sine 2 theta, and I'm going to take y then in this case is going to be equal to cos 2 theta. So in the first case we had our third variable, our parameter if you like, as t. In this case our parameter is theta. So we're looking at trigonometry here really. So let's have a look. We have x equal to 2 theta plus sine 2 theta, and we have y is equal to cos 2 theta. So same as before, we've got to find dy dx. Okay, so we want to find dy dx in terms of theta. So first thing we've got to do is find dx d theta. So let's do that. So dx d theta. So we're going to differentiate x with respect to theta. So that will just give us 2 here. And if we differentiate sine 2 theta, that will give us cos 2 theta. And then we differentiate to 2 theta, we get 2. So we'll multiply by 2. So let's differentiate y now. So we want dy dx. So we've got to differentiate cos 2 theta. Well, differentiate cos, you get minus sine 2 theta. And I'm just going to differentiate the 2 theta as well to give me 2. So I'll put that 2 here, and there's my minus there. So minus 2 sine 2 theta. Okay, so I have dx d theta and dy d theta. Sorry, this should be theta here. Should put theta here. Dy d theta. And that's it. Okay, so now I got to find dy dx. So let's do that. Okay, so dy dx we know is going to be equal to dy d theta divided by dx d theta. Okay, so that's going to give me, in this particular case, dy d theta is minus 2 sine 2 theta, all divided by 2 plus 2 cos 2 theta. Now that's it really. However, I can see here that I've got some double angle formula, or double angle sines and cosses here. So I think I can do something more with these. So let's have a look if I can. So let's have a look. Let's see. I'm going to do. Going to look up I have a set of maths tables, and in those maths tables I've got some trigonometric identities involving double angle formula. So I know that, for example, sine 2 theta. I know that sine 2 theta is sine is 2 sine theta cos theta, and I also know that cos 2 theta, there is a formula in there as well, and it looks like this: cos squared theta is equal to a half 1 plus cos 2 theta. So I'm going to use these two here. Now these are in your maths tables, these trigonometric identities, so I'm going to use these to kind of tidy this up a little bit. Now, first thing I'm going to do here, actually, before I do anything else, is I can see I've got a 2 multiplied by this here, I've got a 2 here, plus I've got this 2 multiplied by this here. So I'm just going to multiply above and below, or sorry, divide above and below by 2. So on the top I'll end up with minus, if I divide all of this by 2, I get sine 2 theta. And if I divide these two here by 2, I'll get 1 plus cos 2 theta. Okay, so let's move down here then, and I'm just going to tidy this up a little bit. So let's see, I've got a sine 2 theta here, and I know that sine 2 theta is 2 sine theta cos theta. So instead of sine 2 theta, I can write in, well, there's a minus here anyway, so I've got to keep that. Okay, so I've got a minus 2 sine theta cos theta. Now, on the bottom here, I've got a 1 plus cos 2 theta. I've got a 1 plus cos 2 theta here as well. That will be equal to, if I multiply this side by 2, I'll get rid of this half here. Multiply this side by 2, I'll end up with 2 cos squared theta. 2 cos squared theta. 2 cos squared theta. Okay, so all of this is just equal to all of this here now. I can see here that I can divide this 2 by this 2 here, and I'll just end up with minus sine theta cos theta. On the bottom here, I can do, I've already gotten rid of this 2 here. I've divided 2 by 2 here. I've got a cos squared theta here. Cos squared theta is just cos theta times cos theta. Okay, and just to finish this off then, I know that sine theta divided by cos theta is tan theta. I've still got this minus here, I'll just stick that in there. And I've got this cos theta divided by cos theta, which is just 1. So my final answer then is just minus tan theta. So dy dx is minus tan theta. So there are my two examples for parametric differentiation.